Hi, I'm Romeo and I'm gonna record the video of the solution for question 5 in homework 2 for the course probability and stochastic processes. So as you can see, the question defines the probability of the number of customers arrives in a store during a time from 0 minutes to 2 minutes equals to k. Probability is defined as the following equation, which is e to the power of negative lambda times t times lambda times t to the power of k divided by k's factorial. So, and the question 1 asks us to find the lambda. And also the question, suppose that the probability in 2 minutes at least one customer arrives at the store equals to 0.3. So we can use that to solve the first question. First is to find lambda. So from the question we can know that the probability of at least one customer arrives within 2 minutes is equals to 3, and then we can get that by using this 0.3 is one minus the probability of no customer arrives in 2 minutes is also equals to 0.3. So we can get that the probability of no customer arrives in 2 minutes is 0.7. So this can also be written as this equation right here. So you can write that as the number of customer arrivals in during 0 to 2 minutes equals to 0, and we set the t equals to 2 and k equals to 0, and we can put the two values into the equation so we can get the lambda times 2 times lambda times 2 to the power of 0 and 0's factorial. So this right here equals to 1, so this equation equals to e to the power of negative 2 times lambda, and we know that equals to 0.7, and we can use that to solve for the value of lambda. So we take the line for both sides, and the left side equals to negative 2 times lambda, and the right side equals to ln 0.7. So lambda equals to ln 0.7 divided by negative 2, which is I'll calculate that, which equals to 0.178. So that's the value for lambda. So the second question asks us to find the probability that in 3 minutes no customer comes. So we can also write as the form of this. So it asks us to find out the number of customer arrivals in a time period during from 0 to 3 minutes equals to 0. So it's equals to times 3 times divided by 0 factorial. So this right here equals to 1, and so this equals to e to the power of -3 times lambda. So since we already know the value of lambda, so we can put the lambda into this equation. So which is equals to 0.586. I've already calculated that. So for the third question asks us to find the probability that in 10 minutes at least 2 customers arrive. So to find that in 10 minutes at least 2 customers will arrive. We cannot directly use this form right here, so we're gonna change this form. It's equals to 1 minus the probability in 10 minutes. Sorry. So at least 2 customers. So it equals to 1 minus the probability in 1 minute at most 1 customer arrive. So it's equals to 1 minus probability of the number of just forget that. So in a time period from 0 to 10 equals to 0. Plus the probability of the number of customers arrivals in 0 to 10 equals to 1. So this right here is the probability in 10 minutes at most 1 customer arrives. So we can write this probability into this with this equation right here. So it's this part right here equals to 1, so write directly as e to the power of -10 times lambda and minus e to the power of -10 times lambda and times 10 lambda. So and then we put the value of lambda into this equation. We can get times 1.0. We can get the final answer as 0.531. So that's the answer to the questions number 3. So and there is the last question. Number 4. So number 4 asks us to find the probability that in one minute exactly 1 customer will arrive. So we can like directly use the form provided. So it's equals to the probability of the number of customer arrivals in exactly in 1 minute, so it's in a time period from 0 minute to 1 minute, and equals to 1, which is equals to the t equals to 1 and k equals to 1, so times lambda. So it's e to the power of negative 1.78 times 1.78, which is 0.149. And that's the answer to this question. Thank you for watching.